on this or bind function. Okay. So when you set up cost matrix for misclassification cost, okay, so you have to set up this or bind function. Okay. But you need to make sure that you set it up correctly. And what or bind does is, or bind doesn't care false positive, false negative, or whatever. So it takes the test. Or bind can have any number of vectors. All it does is that it just takes one vector after another and put them as rows and bind them all together. That's what or bind is. Row bind. R stands for row. So what this is going to do, you're going to put 0 and 15 as first row, and then you put 3 and 0 as the second row. So now it has a matrix of 2 by 2. Okay? And then you're going to just simply multiply that with this, with your confusion matrix. Okay? And then give you the product sum. Okay? So now, what numbers you put here in this RC bind or R bind must be such that these numbers correspond with the correct cost of false positive and false negative. And what is false positive and what is false negative depends upon two things. One is whether you have actual class as columns or rows. You can have either way. Or produces actual classes going as columns and predicted classes going as rows. So that's what R does. The classification matrix always produces actual classes like that and predicted classes like that. Okay. But other software packages may have the actual classes going row-wise and predicted going column. So you have to pay attention to that. But the second thing is, which of these two classes is the positive class? Now, if it is numerical, R will always put 0 as the first one and 1 as the second one. Okay. And usually when you have zeros and ones, 1 is the positive class. Usually. It could be different, but that would be an exception. Usually that would be the case. But sometimes you may not have zeros and ones as the class. You may have like yes and no, or male, female, or whatever else that you may think of as non-numerical labels. So in that case, it is not obvious that which one is positive and which one is negative. So you have to look at what is the positive class and what is not. So in this case, an owner and non-owner, okay, so you can have two possibilities. You can have positive case as non-owner, in which case, this is what the matrix, this confusion matrix is going to be like. So you're predicting non-owner, which is positive class, so you're predicting positive, but it ends up, the actual ends up being owner. So it was predicted positive falsely. So this is false positive. And this will be a false negative. So when you set up your R bind, so your R bind should be, the first row should be 0 and the cost of false positive. The second row would be cost of false negative and then 0. Okay? So that's how you set up your R bind. Now if it was the other way, suppose if positive case is owner, then if you predict non-owner, then you're predicting negative. Okay? And if the actual class turns out to be owner, then that would be false negative. You falsely predicted negative. So that would be false negative, and this will be false positive, and the cost will be like that. Then you have to set up your R bind in this fashion. 0, 15 as the first row, and 3, 0 as the second row. Okay? And of course, if the rows and columns are switched around, and again, you have to figure out what is false positive, what is false negative. Okay, and then first row goes as the first vector in all bind, the second row goes as the second vector in the all bind. So step one, figure out where the false positive and false negative fall in the matrix. And then replace false positive with the cost of false positive, replace false negative as the cost of false negative. Put the first row as the first vector, put the second row as the second vector. Then you will be fine. Okay?